Hi students, in today's video we are going to discuss about the chapter number 10, which is wave optics. So we already know about what is called optics. Optics is a branch of science that deals with the study of the behavior of light. So it has two parts. The first part is geometrical optics or wave optics that we have studied in the previous class. In today's class, we are going to study about the wave behavior of light. As we know, light is electromagnetic radiations. Electromagnetic radiations are transverse in nature. So, we will study about the wave behavior. Before we start discussing this topic, we need to recall about what is a wave. What do we mean by a wave? A wave is a disturbance, right? A wave is a disturbance. A wave is a disturbance that causes the propagation of energy. A wave is a disturbance that causes the propagation of energy. Now, important point you have to understand here is regarding a wave. That is nothing but a disturbance, right? A wave is a disturbance. Now, when it comes to this topic, our discussion lies in what is called, a wavefront. It is an important definition here to understand. So, wavefront. What do we mean by a wavefront? We can define a wavefront as a wavefront is the locus of. A wavefront is the locus. That is not correct. A wavefront is the locus of all disturbances. Locus of all disturbances which are vibrating in the same phase. Locus of all disturbances which are vibrating in the same phase. All disturbances that vibrate in the same phase are called a wavefront. Wavefront is the locus of all disturbances. What do you mean by locus? Locus means collection of all points which have the same characteristics. Locus of all means. Locus means collection of points which are having similar characteristics. A circle is a locus in a plane. A sphere is a locus in space. So these kind of things you have to understand. Now we have to discuss about the types of wavefronts. Types of wavefronts. Types of wavefronts. The first type of wavefront is what is called spherical wavefronts. Spherical wavefronts. So what do you mean by a spherical wavefront? So we can say a spherical wavefront. Just imagine like with the Gauss's law. Around a point source, the Gaussian surface is a sphere. Just like the way. So wavefronts associated with a point source at a finite distance. So wavefronts associated with a point source at a finite distance, that is called a spherical wavefront. So that means you have a point here. Around this point I can say. So in 3 dimension. So around the point source in 3 dimension you have to say this is the kind of wavefront associated around the point source. So this is what I can say regarding a spherical wavefront. The second type of wavefront we are going to discuss is regarding cylindrical wavefront. Again, we will correlate with the Gauss's law. So, for a line of charge, the Gaussian surface is a cylinder. The Gaussian surface around a line of charge is a cylinder. Just like the way we have a line source of light. The wavefronts around that line source of light is nothing but spherical wavefront. So this is spherical wavefront. Sorry, cylindrical wavefront. This is cylindrical wavefront. Cylindrical wavefront. Cylindrical wavefront. Cylindrical wavefront. Cylindrical. Yeah. Cylindrical wavefront. So these are wavefronts around a light source at a finite distance. The wavefronts around a light source at a finite distance is cylindrical wavefront. Now we have the third type of wavefront, that is called a plane wavefront. So that type of wavefront is what is called a plane wavefront. So what do you mean by a plane wavefront and where is plane wavefront arises? So I have to say a plane wavefront is wavefronts associated with a line or point source located at a large distance, very large distance I tell you. In theory we say infinite distance. Okay, so the wavefronts associated with line or point source located at infinite distance. For example, what is the wavefront of light coming from the sun? Wavefront associated with light coming from the sun. Where is sun located? Sun is located at a very large distance. Therefore, the wavefronts associated with the sun is nothing but a plane wavefront. Because light is coming from a far off source, in that case the wavefront is a plane wavefront. I hope this idea is clear. So in the next discussion, what I am going to see is regarding the most important theory of this chapter. Most important theory from this chapter, that is Huygens wave theory, or sometimes we say Huygens wave theory. Huygens wave theory. Before I start this discussion, let us just understand about something that we have seen in our daily life. Take a bucket of water, or take a trough of water, whatever utensil you are having, take it, no problem. Drop a stone into that water. Drop a stone, a small stone into that water, or just dip a pin into that water. What happens then? As you will say, sir, ripples will be formed inside the water. What type of ripples? So this is where the stone is striking the water. So first, initially such a ripple is forming. After some time, this grows to this size. After some time, this grows to this size. After some time, this grows to this size likewise. Now the question, okay. So this is a t equal to 0. This is a shape at t is equal to t1. This is a shape at t is equal to t2. This is a shape at t is equal to t3. This is a shape at t is equal to t4. So all. Question, how is it possible? What is the reason for all this? What is the reason for formation of such kind of ripples? Now you will say, tell me the answer that you have given the first definition of wave. What is a wave? A wave is a disturbance that causes the propagation of energy. As well, you can see that There is a disturbance over here. Now this disturbance will cause the propagation of energy like waves. This disturbance will cause the propagation of energy like waves. This will cause the propagation of energy like waves. This will cause the propagation of energy like waves. This will be so energy is propagating like waves. This is what you are going to tell me, right? I hope this is what you will tell me regarding what the propagation of energy. Yes, I want that here. Now, I will just go over these points. Now, this is where the story is striking. This is the point of striking of the storm. Story is striking here. Let me tell you, the point S is the center of disturbance. The point S is the center of disturbance, right? Now, around the center of disturbance, ripples are forming. This is a ripple. Now, I will draw with another figure. So, this is the center of the disturbance. S is the center of disturbance around this one. Where ripple is forming. So, this is what at a time t is equal to t1. Now, we can call this circle in 3-dimensional sphere, but on the surface of water it is a circle, right? Now, this is a collection of disturbance, I can say. Why? Because it is a wavefront. Wavefront is a collection of disturbances, right? Which means collection. So, this wavefront 1 is a collection of disturbance. So, that means every point of this wavefront now can be treated like different storms. Understand that? When storm strikes this point, that point is caused by a disturbance is caused by that point. So, if you look at this wavefront as a whole, look at this wavefront as a whole, you can understand that it is nothing but a collection of storms, right? Now, this is a point of disturbance. 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 These are all different points of disturbance, right? So, when this was a point of disturbance, a circular ripple was forming like this. Which means, if this is the point of disturbance, you have to see a circle here, right? When this is the point of disturbance, you have to see a circle like this, right? When this is the point of disturbance, you have to see a circle like this. Okay, so every point is having such a circle forming, right? Now, this wavefront is called primary wavefront. Then this is called secondary wavefront. Question: what is the source of primary wavefront? This S, right? S produces this primary wavefront, right? What is the source of secondary wavefront? All points on the primary wavefront is the source of secondary wavefront, right? All points on the primary wavefront is the source of secondary wavefront. Am I right? All points on the primary wavefront is the source of secondary wavefront. All points on the primary wavefront is the source of secondary wavefront. OB basically will ask me a question. Sir, then take another point on the secondary wavefront. Will that cause another wavefront? Here we say, or saying yes, it is possible, right? In that situation, we will call this by the name tertiary wavefront. Tertiary wavefront. But we are not taking it. Why? Because so S is the source. If I call this point as S1, the disturbance caused by S will be much greater than the disturbance produced by S1, right? Why? Because this wavefront is as a result of the disturbance of S. That energy of this S is now distributed to all points on the primary wavefront, right? The disturbance of S is now distributed to all points on the primary wavefront. So that means this point is getting only a negligibly small fraction of that energy. Now around this point secondary wavelet is generated or secondary wavefront is generated. The energy of the secondary wavefront is much smaller than the energy of the primary wavefront, which means energy of the tertiary wavefront will be much smaller than the energy of the secondary wavefront. So that means what I say, in comparison, tertiary or quaternary can be neglected because the energy processed by such wavefronts are negligibly small. Now we come to an important sentence of the Huygens wave theory. So what is this? This is a point on the primary wavefront. 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 This is causing a secondary wavefront. This is causing a secondary wavefront. This must cause a secondary wavefront. This will constitute a secondary wavefront. Every point on the primary wavefront causes a secondary wavefront. Alright? Every point on the primary wavefront must cause a secondary wavefront, right? So that's where I am coming to the important sentence of Huygens wave theory. Every point on the primary wavefront, every point on the primary wavefront acts as a source of new disturbance every point of the primary wavefront acts as a source of new disturbance from where secondary wavefronts are generated. From where secondary wavefronts are generated. Right, so every point of the primary wavefront, so this is the primary wavefront, act as a source of new disturbance from where secondary wavefronts are generated. So this is primary wavefront, this is secondary wavefront. From every point on the primary wavefront you are having a secondary wavefront. Then the next point. Now the question. So this is a wavefront, right? This is called a plane wavefront. Now this point is a source of secondary wavefront. This point is a source of secondary wavefront. This is secondary wavefront. This is secondary wavefront. Let me say this is a directly is equal to V1, right? So we can see that around this wavefront there is something of some radius I'm saying. Okay. Now I can say that. So what shall I do in order to, okay, I'm going to draw a common tangent here. Say between the hours having these wavefronts. So this is a rough estimate only, don't think so. Now what I am saying is that in this case the energy is propagating in this direction, so we will avoid this part. The backward part of the wavefront can be avoided because it's an ad hoc assumption made by Christian Huygens. Since energy is propagating in this direction, we will consider only what is called a forward envelope. We will consider only what is the forward envelope. Forward envelope, that is envelope in the forward direction. Now I can say that this is the location of the primary wavefront at a time t1 plus tau. I would draw what I have said. I would draw a common tangent to the secondary wavelengths. Common tangent. So this the figure may not resemble the same, but actually you have to assume that it touches exactly one point of this wavefront. So we can say second aspect of Huygens wave theory is common tangent. This is a very important topic in the board examination point. Common tangent drawn to the secondary wavelets or wavefronts. Wavefronts are otherwise called wavelets at any instant. Is the primary wavefront. Is the primary wavefront at that instant. The common tangent drawn to the secondary wavelets at any instant is the primary wavefront at that instant. So if you want to get a primary wavefront at a time t, what you have to understand is that you have to draw a common tangent. Simply draw a common tangent, man. You are going to get the primary wavefront at that instant. You will get the primary wavefront at that instant by drawing a common tangent. Now it means the energy is propagating in this direction. If I say this distance is d, then easily we can see that distance is equal to c into t. What is c here? C into t no, sorry, c into time interval is no. The distance between the two primary wavefronts at any time is c tau, where c is the speed of light. Speed of light. So c tau, c is the speed of light. So that means the wavefronts are propagating. Wavefronts are propagating at the speed of light. Wavefronts are propagating at the speed of light. So let me tell you, d is equal to c tau. So wavefronts are propagating at the speed of light. So that is what I am saying. So let us come back to the statement of Huygens wave theory. First statement is every point on the primary wavefront. A wave is a distance. So here you will bear in mind that particular sentence, that a wave is a disturbance. Every point on the primary wavefront acts as a source of disturbance from where secondary wavelets originate. The common tangent drawn to the secondary wavelets at an instant is the primary wavefront at that instant. These are very, very important points, I would say. Now, energy propagates in a direction perpendicular to the wavefront. Energy propagates in a direction perpendicular to the wavefront. So, these lines show plain wavefront. Energy propagates in a direction perpendicular to the wavefront. So, understand that. Energy propagates in a direction perpendicular to the wavefront. So let's come back to the definition once more. According to Huygens wave theory, every point on the primary wavefront acts as a source of new disturbance from where secondary wavelets are generated. Repeat, every point on the primary wavefront acts as a source of disturbance from where secondary wavelets are generated. Right, every point on the primary wavefront acts as a source of disturbance from where secondary wavelets are generated. Then what is the second point? The tangent, common tangent to the secondary wavelets at any time is the primary wavefront at that instant. Common tangent drawn to the secondary wavelets at any time is the primary wavefront when at that instant. Right, so that is regarding the Huygens wave theory, Christian Huygens wave theory, I will say. Now we will consider the types of wavefronts associated with certain conditions. So let us start for a convex lens, as we have studied in the previous classes regarding wavelengths. So actually ray is always perpendicular to the wavefront. Ray of light is always perpendicular to the wavefront. So let me consider a parallel beam of light inside here. A parallel beam of light is incident on a convex lens. So I can say that you will get the image at the source, right? Okay, so here I can say for a parallel beam of light, means the source is located at infinity. So the wavefront must be a plane wavefront. It's a plane wavefront because light source is at infinity. So red colored line shows the wavefront and white colored line is the incident ray. And you can see that the energy propagates in the direction perpendicular to this. This is incident wavefront. Now after refraction, you get the image here, right? You're getting the final image here. It's a point image. So what will be the type of the wavefront we have to consider? It is spherical wavefront. So this is the source. Yes. 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 This is how we are going to get the images, right? So incident wavefront, a refracted wavefront for a convex lens. Now let's consider for the next one, that is for a concave lens. Okay. For a concave lens, so here a parallel beam of light is incident. A parallel beam of light is incident here. So where are we going with the image in this case? Where are we going with the image? So wavefront has to be, right. The incident wavefront is just like the previous incident plane wavefront. In this case, you have to understand that these rays appear to converge to the focus, right? Now in this case you can see that this appears to come likewise, and okay, there is a similarity by which you can understand this. Look at the shape of the first refracting surface, look at the shape of the emerging wavefront. Look at the shape of the emerging wavefront. So both look similar. Now I will insist you to draw for a concave mirror. So this is a parallel beam of light. So I want you to draw the incident and the refracted wavefronts for a concave mirror